Welcome to today's notes covering how to convert from moles of one substance to the mass of another. If we recall from our last set of notes, we converted from moles of one substance to mass of another. Now we're just going to add a second step to that. Again, stoichiometry in chemistry is kind of like our sandwich problem where let's say we need to make 2,000 sandwiches. How many slices of cheese do we need in our extra cheesy cheese sandwiches? Except in this term it's in chemicals, so if we need to make 14 grams of water, how much reactant do we add? Alright, so again I'm going to run through the steps as I work through a sample problem. Step 1, we are going to write the balanced chemical equation. Alright, our problem is in a synthesis reaction where I introduce 6 moles of chlorine to excess iron 3, what mass of iron 3 chloride is produced? Alright, so we're going to add 6 moles of chlorine to excess iron 3. Chlorine, have no fear of ice cold beverages. Chlorine is a diatomic element, one of our 7 plus 1, to excess iron 3 plus Fe, because that's just the plain elemental iron. Our product is iron 3 chloride. Since iron has a charge of 3 plus, we know that from the 3. Chlorine has a charge of 1 minus. Our product is FeCl3. Now, in order to balance this, least common multiple between 3 and 2 is 6. So we're going to put a 2 here, a 2 here, and a 3 there. Step 1 is now done. Okay, step 2. Once we have the balanced chemical equation, we can convert from moles of chlorine to moles of iron 3 chloride. This is our mole bridge. So we're going to convert from moles of A to moles of B. Again, this is our mole bridge. This is the only way that we can convert from one compound to another. Again, when we use the mole bridge, we need to use coefficients as our ratios on the right. Alright, so if we start with 6 moles of chlorine, 6 mole chlorine, then on the bottom right hand corner we need to put the exact same unit. So we're going to put moles of chlorine. In the top right hand corner we are looking for iron 3 chloride, or FeCl3. So we're going to write moles of FeCl3 on top. We can only convert between we can only change either the unit or the compound, but we can't change both in one of these tools. So in this case we're going to convert from chlorine to iron 3 chloride. Now our ratios over here, moles of Cl2 is going to be 3, and FeCl3 is going to be 2. 6 times 2 is 12, divided by 3 gives us 4, equals 4 moles of FeCl3. Now, that's not what we're looking for. We're looking for the mass of iron 3 chloride. So in order to convert from moles to mass, we're just going to go back to last semester and convert from moles of B to mass of B. And this is just a simple molar mass problem. So we're going to use the molar mass from the periodic table. And always remember that with the molar mass, it's always that mass over 1 mole, no more. So if we're given 4 moles of FeCl3, we need to pull out our periodic table. And on the right, we have the same unit. And then on top, we have grams of FeCl3 because that's what we're looking for. Again, we said there's always 1 mole. And then the molar mass of FeCl3, we see the mass of Fe is 55.85. And then chlorine has a molar mass of 35.45. And we have 3 of those. So we say 35.45 times 3. All right, pull out our calculator and we see 55.85 plus 35.45 times 3 gives us 162.2 grams per mole. And again, that's grams per 1 mole, which we see right here. So we write down 162.2, multiply that by our 4 moles of FeCl3. That gives us our answer, which is 648.8 grams of FeCl3. All right. As you see, we really didn't do anything new today. All we did was took a handful of other steps and squished them all into one. Remember, the only way that we can convert from one substance to another is by crossing the mole bridge, no other way. Then once we've crossed the mole bridge, it's just a simple conversion problem from moles to mass. All right, enjoy.